The Kirkendall Effect by Christy Lucas, Austin Rosso, Cynthia Shannon, and Alexis Weckel. Diffusion is the movement of atoms within a material. This can often be seen by adding food coloring to water. The water molecules disperse through the water to change its color. The movement of atoms occurs in gases, liquids, and solids. This video will focus on solid-state diffusion, or atom movement in solids, and the discovery of the Kirkendall effect. There are four main mechanisms of atom movement within solids: direct place exchange, ring diffusion, interstitial diffusion, and vacancy diffusion.
Direct place exchange occurs when neighboring atoms switch places. This creates a high amount of strain within the crystal structure. It is now not believed to occur often and may only happen in amorphous materials. Ring diffusion is similar to direct place diffusion, but involves more atoms. The more atoms involved, the less stress on the crystal structure of the material. This type of diffusion is also very uncommon because multiple atoms have to move simultaneously.
Interstitial diffusion often happens when the diffusing atom is much smaller than the bulk atom. The interstitial atoms fit in between the atoms of the crystal structure. Common interstitial atoms can be remembered by BONCH, or boron, oxygen, nitrogen, carbon, and hydrogen. This is the type of diffusion that takes place in steel. Ernest Kirkendall was born in Michigan in 1914. In 1935, he received his master's from Wayne College, and in 1938, he got his PhD in metallurgy from the University of Michigan. The types of diffusion previously mentioned were considered standard, but with the results from his experiment, he challenged these mechanisms.
Kirkendall experimented with the brass system, but his conclusions could be applied to many alloy systems. To test diffusion, Kirkendall set up an experiment with copper electroplated zinc. He concluded that there was a greater mass shift of zinc into copper, causing the boundary to move toward the zinc edge. These results did not match with the previous diffusion theories and were challenged by other scientists. To verify his previous conclusions about the diffusion of copper into beta brass, Kirkendall set up an experiment where molybdenum wires defined the boundary between the brass and the copper. He observed the movement of the interface after an extended period of time and concluded that the brass core shrunk. Kirkendall's experiments proved that atoms move through vacancies in most solid materials rather than any of the previously mentioned mechanisms. There are always vacancies in materials above 0 Kelvin. Once one atom moves into a vacancy, another vacancy opens up, allowing other atoms to move. These conclusions help us predict the diffusion in different alloy systems.